All right, welcome to today's lesson on identity matrices and inverses and determinants by a product. So we're going to look at first of all the idea of a multiplicative identity, which is just here. And it's very long or big words, but it actually has a really simple meaning, which everyone is familiar with. All right, so two numbers whose product is the multiplicative identity are called inverses. So it's just a fancy way of saying something like this. So this product is the multiplicative identity, and these two numbers here are inverses of each other. So 3 is the inverse of a third, and vice versa. And what that means is when you multiply them together in either position, so 3 times a third or 1/3 times 3, the answer is the same. And you might remember from the previous lesson about multiplication of matrices that multiplication of matrices doesn't always work in that way, in that two matrices A times B is not always the same as B times A because of the order that things happen in. Now what we're looking for here is we're looking to have a matrix at the start, we might call this one A, and we're looking to multiply it by its inverse so that the answer is 1, all right? But you might remember that matrices don't always look like a single number, so it's not just a simple matter of putting 1 over that number and calling that the inverse. All right, matrices are arrangements like this, and so when you find the inverse, it's going to be a lot more complicated. All right, so let's start by looking at a square matrix to begin, because those are the most common. All right, so we'll have a square matrix, and it might be A equals 2, 3, 1, 4. All right. Now, notice as well that over here we had a digit multiplied by its inverse equals 1, but matrices are not represented by a single digit, they're represented by a number of digits, so therefore 1 is not going to be represented by a single digit, it's going to look like a matrix. So I'm here to tell you that the identity matrix, or the answer of 1, which we always call I, for us, this 2 by 2 square matrix, the identity matrix is this. All right, you might notice there's a couple of features here. It's got zeros on diagonals and ones on the opposite diagonal. All right, so this is the identity matrix for a 2 by 2 square matrix. All right, so this is essentially saying that this is the same as 1 for matrices, right? Because we know that a matrix is not given by one single digit, so therefore this 1 can't be a single digit either. It has to look like a matrix. So it's got 1s on this diagonal and zeros elsewhere. All right, so now what we're looking for, given this matrix here, we're looking for something that, oops, sorry, not times, where this will happen. So A times B equals the identity matrix, or B times A equals the identity matrix. All right, so we're looking for this, this matrix here, B, that when we multiply it by this one here, which is A, the answer is always I, okay, or the identity. So I'm going to instead of using this equation here, A times B equals I, I'm actually going to set it up. So it's going to be 2, 3, 1, 4, which is A, times B, which is going to be another matrix, 2, 2, 2, 2. All right, equals 1, 0, 0, 1. All right, so you can see there that A times B equals the identity matrix. And you can also see there that if I was to divide this side by A, I would get B by itself. Now, division of matrices is not something that we have done, is it? So it needs to be 1, 0, 0, 1 over 2, 3, 1, 4. So knowing the division of matrices is not something we've done, let's take a step back and see what else we could do. So what I'm going to do is I'm going to put variables into this equation here. All right, then I'm going to write out the multiplication equations that would eventuate if I was to multiply equation A by equation B. All right, so it's going to be it's going to be 2 times x plus 3 times u. Remember, it's rows by columns. And then over here, it's going to be 2 times y plus 3 times v. Then down the bottom, it's going to be 1 times x plus 4 times u. And then the last position is going to be 1 times y plus 4 times v. All right, so we'll simplify those and we'll get 2x plus 3u. We'll get 2y plus 3v. We'll get x plus 4u. And we'll get y plus 4v. Now you might see where this is going, because what we've got now is one matrix on the left-hand side, which is this one here. We've got the x's and y's in, and it equals the one on the right-hand side, which has the zeros and ones. And now, when they're equal, we can just match up the positions, and we can say that 2x plus 3y is the same as, oops, not 0, 1. We can say that 2y plus 3v, because it comes from the top right, is the same as this 0 here. We can say that the bottom left is the same, x plus 4u equals 0, and the last one, y plus 4v equals 1. Now this is a lot of work to find out this missing matrix, and what you would do now is you would plug these equations into the calculator and solve them simultaneously. You would put them all into a system with 4 lines, and it would have comma x, y, v, and u. And then it would spit out the answers for you. Or if you felt like it, you could do it by hand. I'm just going to jump onto the calculator, and it's going to tell me that x equals 0.8, y equals negative 0.6, u equals negative 0.2, and v equals 0.4. All right, so those are the numbers that sit in the B equation. So it goes 0.8, negative 0.6, 0.4, oops, sorry, no, that's 0.2, negative 0.2, and 0.4. All right, so remembering back to the very beginning where we talked about the multiplicative identity and being that one number multiplied by its inverse equaled 1. One number multiplied by its inverse equals 1. And then we're going to zoom over to, oops, undo that move. We'll zoom over to here where we were. And we have this area here. So we've got A times B. Here. A times B equals 1, essentially 1 in matrix form. All right, and this B we didn't know. So this one here is B. The variables we've found are all in the B matrix. And we can also remember that this was A times its inverse equals 1. So then B must be the inverse of matrix A. All right, so we can remember this idea that to find the missing matrix B, we had to find the inverse of the original matrix. All right, and the inverse is also written like this. A to the power of negative 1. So whatever it is to the power of negative 1 is the inverse. All right, and if you try it out with the original example of 3, 3 to the power of negative 1 is a third. And 3 times its inverse equals 1. So A to the power of negative 1 is the inverse, multiplied by the original matrix. The answer must be the identity. All right, so this missing matrix here is B. Now, you don't have to believe me, but if I go to the calculator and plug it in, I will get A times B equals the identity. If I plug it in the other direction, remember order is important for multiplication of matrices, I still get the identity matrix because B was the inverse of matrix A. All right, so the final thing to remember is that I don't expect you to do this every time someone asks you to find the inverse or to find the identity matrix. I'm going to give you a really simple formula, and it is this. The inverse of a matrix is given by 1 over AD minus BC multiplied out the front of D minus B minus C, A. Now, let's make sense of all this. All right, this has to come from a matrix that we already know, and we have to already know the numbers are in what each position. So this is matrix, it looks like this, A, B, C, D. So A, B are across the top, C, D in the second row. So then, whenever we want to find the inverse, we just swap A and D. B and C stay where they are, but we make them negative. And then we multiply the entire thing by a scalar, which is a fraction of 1 over A times D minus B times C. So let's try it out with the example that we did just before. So we had that A was 2, 3, 1, 4. Okay, so we've got A, this is A, that's B, C, and D. All right, so we've got the inverse equals 1 over. Now, what's A times D in this one? 2 times 4. All right, what's B times C is 1 times 3, so 8 minus 3. Then we're going to multiply it by, we're going to swap D and A, so 4 and 2 swap. And we're going to make B and C negative and leave them where they are. All right, now, you might remember from the previous lesson, hopefully you do, that to multiply by this fraction out the front, you just multiply every number inside by the fraction. 8 minus 3 is 1/5. So let's go. What's 1/5 of 4? Hopefully you'll find that it's 0.8. What's 1/5 of minus 3? Hopefully you'll find that it's 0.6. 1/5 of minus 1, you should know, is minus 0.2. And 1/5 of 2 is 0.4. All right, so we've managed to go two different ways. The first way was using simultaneous equations in here, and the second way was using the little formula here. 1 over AD minus BC multiplied to the front of D minus B minus CA. All right, it's very important that you remember there's two steps. You have to multiply by the scalar and swap positions of some elements. All right, so two steps here. All right, now the final thing that you need to remember is a little detail that most of you have probably grown at because it's something I like to bang on about, but it's this little fraction out the front here. And you might look at it and think there's some strange things that could happen in this fraction, and you'd be right. Because what would happen if the denominator at the bottom was 8 minus 8? We would then have 1 over 0. And that is not just the same as 0, that is actually undefined. All right, so this little fraction out here, the scalar, has a special name. All right, and it runs off this. It's called the determinant. It's just like the discriminant in the quadratic factor, the quadratic formula. The discriminant tells us when there'll be solutions and how many. The determinant also tells us when there'll be solutions. So if the determinant is a fraction, there will be an inverse equation. This will work. If the determinant has a 0 on the bottom, then there is no inverse and you cannot go any further. All right, so remember that. It's called the determinant. I've written it wrong. I'll just correct that. It's determinant. Determinant. And you need to remember it because it determines if you can go any further. All right, and really, the determinant is symbolized by det, and it's just the denominator on the bottom. It is not the fraction, just the denominator. And what you're looking for is where it is equal to or not equal to 0. If it's equal to 0, there are no inverse possible, and if it isn't equal to 0, you can keep going. All right, the final thing I want to show you before I direct you to another video is your calculator. And I've got a couple of pictures here of something that I've done on my calculator. So your first one you can do is you can create a matrix, and then you can use that little button to store it as a variable, which makes it a lot easier in future if you're having to use the calculations for other things. So first of all, you enter your matrix using your Math 2 keyboard, and then you store it, and that little button shows up in the top left on each of the top right, sorry, on each of the math 1, math 2, math 3. And then it will just show up in this entry line here as being stored. You can do the same thing with different ones, and that brings me to the next thing. Then if you need to multiply them, you can just go variable times whatever you need to, and it does it automatically. It recalls that you've stored this matrix as that variable and makes the calculation for you. Notice here that I've done A times B, and the result was the identity matrix. So this means that A and B are inverses of each other, or B is the inverse of matrix A. Notice then that I do B times A, and the answer is still this identity matrix. So A times B equals 1, B times A equals 1, and that means that B is the inverse of matrix A.